Three things I covered in my discussion with Professor Teo Wei Peng. Topic 1, near-infrared spectroscopy, also known as NIRS. It can be used to detect oxygen levels in your muscles and in your brain. We covered the technology's use case, advantages, and benefits. Topic 2, how exercise benefits brain function. We covered things like dual tasking, interbrain synchronization, how to exercise for brain health, etc. Lastly, topic 3, his biggest surprises and takeaways from his years of research on exercise and cognition. Let's get into it. Hi Prof, welcome back to the show.
Oh, thank you very much. Thank you for inviting me again.
You were the first guest on the show and now you're the first repeat guest.
Thank you very much. It's a pleasure.
Yeah, I think between now and back then, we did speak a little bit. And one of the topics that came up was near-infrared spectroscopy, in short, NIRS. Well, you recommended I pick up a device, train rate, and I eventually did pick it up. And that's why we're having a second conversation today.
Excellent.
So just to get things started, maybe we can introduce to people who are unfamiliar with NIRS, what is it exactly about?
Okay, so NIRS, as the name suggests, it's using near-infrared light to detect levels of oxyhemoglobin concentration and deoxyhemoglobin concentration in bodily tissue. So we can use NIRS in multiple ways. The two most prevalent ways of using NIRS is to measure muscle oxygenation and, of course, brain oxygenation as well. So as you would know, in the muscle, we use oxygen to metabolize certain processes in the body. Same with the brain as well. So obviously, in order for neurons to fire, we need oxygen and we need all these metabolism processes to happen. So NIRS can measure some of these processes both within the muscle and within the brain.
What are its advantages and disadvantages compared to other possible methods?
Yep. So I think one of the key advantage for NIRS is that it is portable, or it can potentially be portable. The outcomes or the measures that it produces are very similar to MRI. There are, of course, distinct differences depending on what measures you use. And it is also a measure that you can read in real time as well. So if you imagine in an MRI, you are lying down, you cannot really move that much. But in terms of NIRS, we can apply it in a very portable and very mobile environment. Depending on the number of channels or optodes, as we call them, we can measure from very specific brain regions that MRI can measure. Some of its disadvantages, obviously, would be that NIRS measures areas of the brain that are fairly superficial. So unlike MRI measures the whole brain, right? So it can measure superficial, it can measure very deep brain structures as well. So this is one of the key limitations for using NIRS. In saying that, if you compare the cost of using an MRI and using NIRS, NIRS is obviously a lot cheaper, or it's more cost effective for research and for commercial use as well. It is very safe for use in infants and even in older adults and even participants with chronic diseases.
So how do you typically use it in your research and your work?
So a lot of my work looks at the relationship between cognition, or how we think, and how we move, mobility or motor control. So as we know, as we grow older, not only do our muscles deteriorate, but our brain function also decreases. I specifically look at this relationship between brain function and how we make decisions during movement. So there are two ways in which I deploy NIRS predominantly. One is to look at the effects of exercise on brain function and outcome. So I would use like a pre and post measure or pre and post change of their brain activity in specific brain regions. The other way that I deploy NIRS would be to understand how the brain reacts when we are moving. So as I mentioned earlier on, NIRS is very portable. We can wear the device as we move, and it's quite resistant to minute movement. So we can actually look at how the brain reacts or adapts to different situations as we walk or as we control certain actions with our hands and feet.
Is this related to the hyperscanning study that you did?
When we talk about hyperscanning, the term hyperscanning is really to measure brain activity of more than one brain at once. So it is usually measured during an interaction process whereby we are looking at how different people interact with one another. Whilst it is not 100% related, what it means is that NIRS can be deployed or can be used in environments that are highly ecological. When I mean highly ecological, it means in a very naturalistic environment, right? So, for example, if you think about a classroom setting whereby students have to work together to solve a problem, we can employ NIRS techniques to measure brain activity and also to look at how these students interact with one another.
So what were some of the findings from the hyperscanning study?
As the name hyperscanning suggests, it's really to measure more than one brain at once, right? Or more than one brain activity at once. What this usually does, or what this usually measures, is how interaction, or in social contexts, how do participants, whether it's students or adults, interact with one another, and some of the biological mechanisms that underpin this social collaboration. So we use hyperscanning in these sort of modalities or these sorts of studies quite often. How is using NIRS in exercise and hyperscanning relates to each other is it sort of demonstrates that NIRS can be used in a very naturalistic environment and in very practical type of environments, right? So if you think of a classroom again, it is very common for students to be interacting with each other to solve a problem. And this interaction we can actually capture from a neural perspective.
Do you manage to find out which sort of collaborative behavior can enhance this interbrain synchronization and group performance?
So I think a lot of papers, including some of our experiments, what we have found out that obviously the quality of collaboration is important. The more we interact with each other, the more interbrain synchrony we have for each other. There are other studies, obviously, to look at friendship. So obviously, the closer relationship you have, whether it's friendly relationship or a romantic relationship, that shows higher brain synchrony. And it's the same for collaboration in classroom as well. So if we have greater degree of collaboration and higher quality of collaboration, that seems to indicate higher brain synchrony.
How do you measure this sort of collaboration? Was it more communication?
Yeah. So this is, I guess, the key question that we are trying to solve or trying to answer. Can we create collaborative environments either by creating a different pedagogy, for example, whereby maybe problem-based learning, right? So if we give students a problem and they have to solve the problem by self-learning, by interacting with each other, we create an environment whereby they have to be collaborative. The hot topic now in education is to see how we can use AI or how can we leverage on AI to create social contexts or social environments whereby students have to collaborate or they have to engage with each other with the help of AI to solve a problem. So these are some examples in which, I guess, education contexts that we are trying to figure out.
Moving on from there to another study that you did, this one more related to reducing depression in female adolescents.
Mm-hmm.
In your study, you mentioned you did both open scale and closed scale exercises, and then there were some differences, right? Can you tell us more about that?
We've done quite a bit of studies looking at how exercise can affect mental health, can affect cognitive health. One of the take-home messages that we get from some of these randomized control trials is that you need to be very targeted in terms of trying to improve certain outcomes, whether it's mental health outcomes or cognitive outcomes, right? We have tried things like resistance training and cognitive health. We have done things like aerobic training with mental health outcomes. And obviously, we know that exercise is important and it helps us to improve brain health. But I think in order for us to really optimize exercise and optimize its outcome, we need to be a bit more targeted and be more specific with how we employ exercise. And of course, apart from that, is also how do we deploy exercise in a way that the translation and uptake of exercise in the community is also just as high.
How far are you into this exploration?
I think right now we do have a few findings which sort of suggests that, if we combine things like aerobic training or aerobic exercise with some level of strength or resistance type of training, it's sort of complementary with each other, right? So we want to, of course, promote people to exercise as much as they can with targeted rest as well. I guess right now it's also how do we implement these programs into the community such that people across the lifespan, whether it's children or older adults, can take up this exercise easily and readily and willingly, I think. This is probably the biggest challenge for us as a community and society, because we are always very busy with our work, and it's very hard to create environments or behavior change opportunities that will be long lasting, right? I mean, apart from extrinsically motivating people, giving them incentives and whatnot, how do we create people with lifelong passion to actually exercise for health reasons? So I think that's the sort of the focus that we are sort of moving into now.
From what you know, are there certain exercises that are better cognitively at different age brackets?
So I think across the age bracket is really about, and this is, I think, I would say similar across different age ranges, is that they have to engage in task novelty. I think that's one. Exercise intensity is, of course, another one as well, right? So it's the same concept as if we want to increase muscle strength, we have to overload the muscle in specific ways. It's the same with the brain as well. If we want to increase brain capacity or improve brain function, we have to train it to a point whereby there is some level of overload, but not, overloading it too much. So novelty is one way. So learning something that's new, engaging different brain regions, interacting with new experiences, that's the other thing. So learning a new skill, doing a new sport, learning a new exercise, these are all very good examples of how to improve brain health. And of course, we need to be pushing ourselves a little bit, right? So not pushing yourself overboard, but having some level of intensity is obviously good for developing your brain function as well.
I think these are some of the things you found in your meta-analysis for different exercises and how it affects the cognitive function of older adults. Were there any surprising findings from that meta-analysis?
One of the key things would be that sort of multimodality type of exercise, so not just focusing on one type of sport or exercise, is actually quite beneficial, because again, the brain is quite adaptive, right? So if we do the same thing over and over again for a long period of time, the brain gets very efficient and the body gets very efficient, right? So then how do you create an environment whereby it challenges your brain and challenges your body again? So this is a key finding for us, that we want to be doing something novel when we reach a certain level.
And I think we discussed a little bit in the conversation before the shoot. Are there ways we can find out how we are doing in terms of our cognitive function? Is there ways we can test ourselves?
Obviously, to go for a regular checkup. I think as middle-aged adults, especially now in terms of our lifestyle, our diets, our sleeping patterns, it is even more important for middle-age. So we're talking about 35 to 50 years old, or even up to 60 years old, to get our brain checked fairly regularly because of health as well. Cardiovascular risk factors are also big risk factors for brain conditions. So we want to ensure that these are not affecting our ability to perform activities of daily living. I guess the other thing as well is that it's also being cognizant about your own thinking abilities, right? So if you feel that nowadays it becomes a bit more difficult to remember or perform certain things, then it's probably worthwhile to sort of ask if this is normal with your GP, and if your GP feels that there needs to be a bit of a further investigation, then perhaps it's good to get some investigation done. Again, for the general public, it's really just being aware that changes happen, and it happens very often, even earlier on in life. And some people might think that in the early 30s they're still very healthy. Yeah, I mean, most people are, but you will also expect that there will be some changes happening in that 30 to 40 age range as well.
So is that where the cognitive decline starts, similar to the physical decline?
I mean, I won't say cognitive decline per se, but I mean, the brain has the ability to adapt very well and compensate very well. So typically in the earlier phases of life, let's say, again, in your 30s to 40s, we can probably compensate very well and we can mask it very well. So a lot of times, whilst doing the physical task, there's no difference when compared to in our 20s, but maybe the effort it takes is a little bit more, right? So I think it's not just looking at the final outcome that we can actually do it, but how hard it is or how much change in terms of effort it takes for you to do that task. Of course, being fit, being physically fit, being cardiovascularly fit helps to improve the efficiency of your brain function, which is what we want. But in general, I think most people tend to sort of, especially in the 30s, whereby you're focusing on your work, your family, and all these other commitments, you sort of neglect all this, lifestyle behaviors.
I think you did mention prior to our conversation something called dual tasking.
Yeah.
And a way which you can test yourself. Well, I think you can do it at home mostly by yourself. Tell us more about that.
Yeah. So dual tasking is the process of doing two things or two actions at once. So it's a multitasking type of protocol. Typically, it is a motor task and a cognitive task done together. So there are many variations to this. You can be walking and you can be counting to yourself or counting backwards. There are some studies that we have done whereby we are walking and we get them to text to a specific list of words. So there are many ways that we can dual task. One thing that previous studies have shown in dual task is that it's quite predictive of, or actually very predictive of, cognitive decline in later stages of life. So that's a paradigm that we employ a lot in my lab. We can potentially do it on our own, but I think it also requires a bit of knowledge and know-how, and it requires a bit of assessing your function, right? So I mean, there are available tests online that you can do to test different domains of cognition. I think it's probably more important to track how you are changing as you age. So I think that is how we can sort of detect significant time points whereby maybe we need to start intervening in terms of our brain health.
Yeah, on that point you mentioned dual tasking ability is predictive of the cognitive decline later in life. But does it mean that you improve your dual tasking ability now? Decline.
Fair enough, yeah. I guess short answer is not really. Dual tasking is a way to measure your cognitive reserve and the efficiency in which you process information, right? So if you are bad at processing information, which is one of the bigger risk factors for cognitive decline down the track, dual tasking is able to pick it up in a physical way. It's about using the data in a way that is knowledgeable, right? So you need to understand what dual task is and what sort of mechanism it underpins and how it's related to cognitive decline down the track.
Does that mean the intervention is something beyond dual tasking, meaning like eating healthier foods, exercising a little bit more, something along those lines?
Yeah, precisely that. I think it needs to be multifaceted because, again, brain development and brain adaptation requires a multifaceted approach. It's not just a one-size-fits-all. It's the same for exercise, right? If you want to improve cardiovascular health, you do aerobic exercise. If you want to improve muscle strength, you do strengthening exercises. So it's no different from the brain.
Out of all these studies that you have done, were there any particular learning points that stood out to you?
Yeah. I think if I look at collectively studies that I've done, what I am 100% sure of is that the brain is very plastic, even at the older age range, right? Yes, I mean, of course, if we look at how age affects the brain, of course, it affects the brain in many different ways. But the brain is also very adaptable even when it grows old. So I think one thing that we often experience is that a lot of people always say that, oh, I'm old and that's why, I cannot think so well and whatnot, right? But, to me, it's important to note that even if you're old, you can actually do something about it, right? So I think the question is, what do you have to do and how committed are you in preserving your brain health? So I think my take-home message, at least for all the studies that we've conducted, is that, always be active. I think that's one. Physically active, mentally active. Keep a good social circle. It doesn't mean that you have a lot of friends, but you have very good friends that you can relate your problems to. These are all known factors to actually protect your brain health. Go and travel if you can, or go and explore new experiences if you can as well. So I think these are probably key take-home messages that I've picked up through all my studies.
Cool. I think that ends the podcast on a very nice note. Yeah, thank you for your time. And we look forward to more studies and maybe like another shoot a few years down.
Yeah, that's right.
Yeah, I know you have a few more studies that you are onto.
Yeah.
Right. Yeah. So yeah, maybe a future one.
Excellent. Thank you so much.
Thank you. Thank you for staying to the end of the video. If you see us producing more YouTube videos, it's because we expanded our content creation team, and that's made possible by the revenue from our labs testing services. This includes something we are increasingly known for, strength testing, but also other tests like VO2 max tests and testing for muscle oxygenation levels. Some of these clients go on to do personal training with us, and we learn from the domain specialists that we feature on this channel how we can provide even better training and testing services to them. In a way, it is a continuous loop of learning, improvement, and better service. This has even progressed to a stage whereby we are running courses for fellow physios and trainers approved by the relevant regulatory bodies with, for example, Dr. Danny Lam, and in the future, other guests as well. If you'd like to see more content, receive better services, and enjoy them at a grandfathered rate, please feel free to reach out to us today to see how we can help you with your healthy aging journey. I look forward to seeing you soon.